Hello student, welcome to our lesson today where we are going to look at Pn Junction Diode. We start with the definition or how Pn junction is formed. Now we have that a pure semiconductor, which we call intrinsic semiconductor, can be added impurity in the process that we call doping by trivalent and pentavalent atoms at the same time. In other words, we have that one side you dope using trivalent and the other side you dope using pentavalent. So it implies that one half becomes a p-type while the other half becomes an n-type. And remember, now we are talking of one material that is being doped with the two atoms, that is trivalent and pentavalent, at the same time. So we have one piece of atom, so one side becomes n-type and the other side becomes p-type. Now the junction between the n-type and the p-type is what we call the Pn junction. So we are saying through this process a Pn junction is created between the two regions. So we have the p-type, as you can see we have the majority holes as the charge carriers. Then n-type, the negative, we have the negatives or electrons being the majority charge carriers. So this one material or intrinsic semiconductor we have doped using pentavalent and we have doped using trivalent on this side. So the joint or the junction between the two types, the p-type and the n-type, is what we call the Pn junction. Now the n-type or the n region is the cathode. Remember, n refers to negative, and whenever we have the negative, then we talk of cathode, which is a negatively charged electrode. So because we have more electrons, then it becomes negatively charged, and therefore it gives us the cathode. Then the p region is the anode. Again, anode, p is the positive, and anode is positively charged electrode. Therefore p-type gives us what we call positively charged electrode, as shown in this diagram. This will become the anode, this will become the cathode. Now what happens is that when they are like this, the way they are, they will not be like that forever. That is, that we have a distinct junction between the two. No. With the time, the free electrons and the hole near the junction diffuse. When we talk of diffusion, we talk of spreading of particles from where they are higher concentrated. So it implies that the electrons, which are highly concentrated in the n-type, will diffuse through the junction to p-type. And also the holes will jump, or they will diffuse to the n-type. So as that happens, the electrons enter p-zone, while the holes move to the n-zone. And in the process, we shall have mobile charge recombination. That is, if there was an electron here or a hole, as the electron comes here, it will recombine with that hole, and when that happens, there will be formation of fixed ions. The same case, if there was extra electron here and we have a hole moving, then it implies that the hole and electron will combine to form another fixed ion. So that is what is happening in this diagram. The holes are moving from p-type to n-type, and the electrons are moving from n-type to p-type. We continue. The recombination of mobile charge carriers depletes them with region of about 0.001 meters to, we can talk of 1 times 10 to the power negative 6 meters. So that region that we have uncovered fixed ions on either side of the junction is what we call the depletion layer. So the uncovered ions in turn set up a field that stops further diffusion. Remember, now one side we have fixed ion and the other side we have fixed ions. Therefore, they create a potential barrier that prevents any flow, any recombination of those mobile charges. And then when that happens, that region that contains or that is occupied by uncovered fixed ion is what we call depression or depletion layer, as shown in this diagram. there were movement of mobile charge carriers. So as the holes were moving and the electrons were moving, there was a recombination. And when they recombined, they formed what we call the fixed ions. And this fixed ion is what is creating a potential barrier that is preventing any other flow or any other recombination of mobile charges. And by so doing, it creates a depletion layer that we are calling depletion layer, that is about 1 times 10 to the power negative 4 or 1.6 1 times 10 to the power negative 6 meters. This is a depletion layer. So it implies that when this one is created, the p-type will remain on this side and the n-type will remain on the other side. Then we move to the biasing of Pn junction. We start by defining the word biasing. As we have seen, we have the p-type and we have the n-type. Now, when we say that a Pn junction is biased, it implies that we have applied a potential difference between them or across them. In other words, you have connected the P and the N with a conducting wire or with an external source of power. Therefore, we can have forward biasing and a reverse biasing. When we come to the forward biasing, this is where now the Pn junction is said to be forward biased if the p-type region is connected to the positive terminal. Remember, P is representing the anode or the positively charged electrode. So if it is connected to the positive terminal of a cell and the n-type, which is the cathode, is connected to the negative terminal, then that Pn junction is said to be forward biased. In forward biased, the depletion layer will be narrowed. Remember, as you connect p-type to the positive and the n-type to the negative, you are encouraging the flow of mobile charges. In other words, the positively charged carriers will move and the negatively charged carriers will move. So that way, the depletion layer is reduced and more charge carriers or the more charges will flow across the junction. And by so doing, there will be a large flow of current into the circuit, as shown in this diagram. As you can see, they are flowing, they are moving. As they move, they are electrons, they are holes. As they move, you can see the way it is behaving. They are combining. You can see some of the particles combining, as you can see. So as that is the formation of depletion layer. But as you can see here, the anode is connected to the positive. The cathode is connected to the negative. So this one is forward biasing, as you can see. So in the combination, you will find that it is reduced, as you can see now. The depletion layer will be reduced. But this diagram is also showing us how the depletion layer is created. At the end, you find that the depletion layer is reduced. So in reverse biased, Pn junction is said to be reverse biased when the p-type region is connected to the negative terminal and the n-type region is connected to the positive terminal of the cell. So the P is connected to the negative, the N is connected to the positive. So it implies that the cathode will be connected to the positive and the anode will be connected to the negative. That is when we have the reverse biasing, as shown in this diagram. The p-type is negative, the n-type is connected to the positive. So what will happen? This will increase the concentration of fixed ions. So when you reverse here, when you reverse this, it implies that you increase the concentration of positive and negative fixed ions. And therefore, this will thicken the depletion layer. It will thicken the depletion layer. I think you can be able to see how this one is changing as we continue. The first of all, you can see that it is forward biased. Then, as we move, you can be able to see it is forward biased. So reverse biased, you can see how the depletion layer is increasing. So in other words, we are saying when you interchange the terminal like this one, as you can see the negative is the anode, then the depletion layer is increased. And you can be able to see how the recombination is occurring. So this is just a simpler diagram that is showing that the p-type is connected to the negative and the n-type is connected to the negative in reverse, and the depletion layer is thickened. And when the depletion layer is thickened, the potential barrier increases, which in turn increases the resistance. And when the resistance is increased, then it implies that the conductivity is reduced. So therefore, the wider the depletion layer, the higher the resistance of the junction. And therefore, only a smaller amount of current will flow due to minority charge carriers at this process. Only a small amount of current will flow. And that small amount of current that flows due to minority charge carriers is what we call the leakage current. So leakage current is small amount of current that flows due to minority charge carriers. Then from there we have the assignment. So make sure that you attempt all the assignment. If you see that you can't remember, it's always good to go back to your video, listen keenly, and finally come and attempt your assignment. So thank you, and let us meet in our next lesson.